property. Luster, metallic, non-metallic, vitreous, glassy, earthy, all that good stuff. We've got the crystal formation. That's very hard to determine on some of the samples. But flat surfaces, you can compare the angles of the flat surfaces to help you with that, to help narrow down some of the things. The easiest thing to look for is 90 degrees and not 90 degrees, and how many planes there are on those crystals. The crystal structures exist because of the way the atoms line up, the way the elements come together to form bonds, and how those elements structure together. There's the 6 crystal systems that we looked at and we compared our samples to. Streak, the powdered version of the mineral. You scratch your streak plate and you saw, some of y'all saw huge dark streaks, others saw teeny tiny little lines that were not the same color as your sample, and then some of them yielded no streak at all. Why do you think this streak test is ineffective for minerals that are harder than 7?
Well, because wouldn't you have to be able to scratch a diamond, not a, like, it would be relative.
Right.
You would have to have the right block to streak. That's what I'm saying, like, it'd be difficult to.
So if your streak plate is this hard, right, and then you have your mineral sample has to be weaker than the streak plate
Right.
in order to become powdered. Otherwise, you're getting the streak of the plate on
Right.
the mineral. Yeah. Cleavage is the way the mineral breaks, and that's controlled by the crystal structure. The crystal structure is not always what the cleavage ends up with. In your samples today, you have seen examples of crystals that gave no cleavage, that yielded fractures. So you saw no crystal shapes or structures or faces on your broken pieces.
Is that in relation to the hardness?
No,
It's just
it's the chemical bonds and the weaknesses in the bonds, and where it most easily breaks. Yes.
For the math teacher, what do you mean by bonds?
They combine.
How the atoms connect together, how weak that connection is. Or the weaker the atoms are connected together, that's where they're going to break. Minerals don't exhibit cleavage, so they're broken into fracture, like quartz crystals. Fractured. I don't know if you can see how. Okay, so that's okay. Obsidian is what you might call the volcanic glass, and when it breaks just like you see the broken glass or the shards, those curvy pieces, and that's what you call a conchoidal fracture in obsidian. Hardness is the ability of the mineral to resist abrasion or scratching. And so Mo came up with this scale that he related it to the hardness of, like a penny or glass, or things that we can actually take with us in our little test kit out into the field, things that are readily available to you to compare it to. And there's our scale. Specific gravity, we looked at that. That's the comparing the density of the sample to the density of water. The acid test is the reaction of the sample when you drop hydrochloric acid on it. Calcite will react with hydrochloric acid, and that should be the definitive test for you to, that is, if you have one sample that showed up, if anything shows up fizzing, then you know it's calcite. The fluorescence test is that you looked at your samples under the fluorescent light, and that can give you some information.
Should we have had anything that was fluorescent? We didn't.
But you got to see some minerals that did fluoresce.
Yes.
Okay, so here's what you're gonna do. All right, so whenever I put you into groups earlier, I didn't put you with the people that you're sitting with. I did. Well, yeah. So I want you and the people you're sitting around now to go through your data and refer to your handout. Let's see, what page? In your handout 1.7, the mineral identification key. We went through this when we looked at quartz for sample 1. I want you to go through this with all of your samples. And before you write everything down in your chart, you can if you're going to use a pencil, because you may need to go back and regather some data. If something's confusing, you can go look at your sample again. When I did this first, I just went through and I write the sample number below the name of the mineral down here. Okay? If you get 2 of one mineral, that might be okay. So don't think that just because you've already put a number that it's going to be wrong. Okay? So go through. I'm going to give you about 5 minutes to go through and key your samples. Now, start with those unusual characteristics, guys. If you go through this and you can't figure out what it is, the unusual characteristics are going to be a great tool for you to identify what the mineral is.
Oh.
Okay? Yes.